In this video, we'll talk about power and radical functions, and we'll apply our function analysis skills to those functions. So let's start talking about a power function. So a power function at its core is y equals a times x to the power of n. So very simplistic structure, and the idea is we have a couple of different ways this thing can look graphically speaking. So the big part of what's going to dictate it is looking at n, whether it's even or odd. And this is where you have your cubic functions versus your quadratic functions. So if n is even, and then we have to look at, okay, a. If a is positive versus if it's negative. So if n is even and a is odd, or a is positive, sorry, we're going to have our pretty classic quadratic looking thing. So it'll look like x squared. Now x to the fourth, just x to the fourth, is going to look very similar to a quadratic. It'll just be a little bit on the steeper side, but it'll have that same kind of structure to it. If n is even and a is negative, well, you're going to have your kind of more classic quadratic is just going to be flipped. So it'll have everything flipped over going negative. Now if we look at these, we can apply our thoughts of domain and range. So if we look at this one, our domain is all real numbers. Our range is only the positive real numbers. If we look at n behavior, both ends going off to positive infinity. It has symmetry about the y-axis. It's decreasing from negative infinity to 0 and increasing from 0 to positive infinity. And we can apply this thought to all of these functions. So I'm just walking through it with this example because once you see the graph, all that kind of becomes clear. Okay, so if we carry on to if n is odd. If n is odd and our leading coefficient is positive, then we have kind of like our classic x squared look to it. It'll have that radial symmetry. It's going to go through the origin. Domain and range will both be all real numbers. The n behavior is one end, the positive end is going to go off to positive infinity, the negative end is going off to negative infinity, so on and so forth. And then if we look at the case where our leading coefficient is negative, well, we're going to have this structure where it's flipped, but it'll still have that radial symmetry, the difference being that my negative end goes off to positive infinity and my positive end goes down to negative infinity. And if we look at a cubic versus a quintic, very similar to a quadratic versus a quartic, it's just going to be a little bit steeper. And that would be the main difference, but it'll still have a lot of the same tendencies. And those cover all of our power functions. So now let's talk about radical functions. So a radical is basically the square root sign. However, there's a slight difference here. We're going to look at what happens as I do higher roots. So cube roots, fourth roots, fifth roots, sixth roots, that's what this n is going to dictate. So similar to the power functions, n is going to dictate what my graph looks like. If n is even, well, we get our standard square root function, where it kind of has this lazy arc that'll come out. And that deals with the idea that, okay, if I take x squared and I reflect it over the y equals x line to try and find an inverse, well then I only get the positive half. Because if I have the negative half, I no longer have a function. And that causes a problem. So we kind of cut off a piece of it. We slice it right down the middle. We only keep the positive half of that curve. And that's what results with our little lazy arc here. And if we do that with x to the fourth, same thing. x to the sixth, same thing. So this covers all of our even possible root functions. And then we look at the case if n is odd. It's going to look a little bit different. It's going to look kind of like our quadratic, except it's going to have a negative side of the curve. And if you think about x cubed, and you give it the same reflection treatment over the y equals x line, well, it's going to look something like this. It's going to flip. Now, if I have a higher degree, so if we're talking about a fifth, well, it's going to get a little more gradual, but it'll still have the same kind of tendency. And that would make sense because if we think about a power function, a quintic is going to be steeper, so if I rotate it, it's going to be more gradual. And those cover our radical functions. You could go in and talk about the negatives and positives of each case, but by and large, we don't so much worry about those because they don't pop up very often. And that would be the graphs for power and radical functions, just kind of a quick overview of what they would look like. And what we'll largely do is apply our function analysis skills to these various functions to see what happens if we're looking at the whole function.